Hello, this model shows objects following using JetBot on Jetson Orin Nano with YOLO. You could test different YOLO models and sizes, like the version 8, the latest 26, Nano or the small version, and select based on the performance. And initially, we need to import required libraries for this demo, including Ultralytics, which is a Python package that provides implementation of YOLO models and tools to train and test and run them. And we are going to start with loading YOLO-26, the small model. If it is available, it will take it directly or download it if not available. And then we'll load the camera and use the image size of 640 by 640, which is the default size for YOLO. Here we are loading a list of class names, Coco classes, into a variable, and we could take one frame from the camera and pass the image to the model, and this cell will list all the detected and degree of confidence. For example, it detects banana, mouse, TV, bottle, keyboard, with the confidence, different confidence. And this cell will show the image with the boundary box around the detected, or we could have a text widget that we'll use it later on, shows the detected object. And before we start with our JetBot, let's use the path of our JetBot. And for our JetBot to follow the object, we first start by loading collision avoidance model, which we built from previous demo, and we need our object to follow without colliding. And first we are creating a robot object from robot class. And this cell is the main cell, which includes initializing of our widgets and define different functions, including detection centers, which calculate the center of coordinates, coordinate centers of detected object, and function to define which one is the closest detected object. And the flow of our code is starting by taking a new image from the camera, and it will pass the image through the collision avoidance. And if it detects any kind of blocked items, it will add a variable that it is blocked, and then it will pass the image through the YOLO model and will give us an image with the detected object. And if it is blocked, it will then, based on the location of the detected object, if it is right or the left. Otherwise, it will change the speed of the motors, the two motors, so it's trying to follow the object. And here we are going to choose the track label as a person. We could change it if we wanted to track another things. And we start to observe the camera and increase the speed. For example, we make it like 0.6, and I will that like that. You see, it's trying to follow me. If I go to the back, you can see change the direction. Reach to the edge, it will stop. It will not go outside the edge because now it detects a collision. Now we need to stop our robot and stop the camera. Thank you.